Alrighty. Hello, everyone. I'm Zackory Erickson. I'm a new faculty member in the Robotics Institute, where I'm leading the Robotic Caregiving and Human Interaction Lab. And my group's research focuses on healthcare robotics towards the development of robotic caregivers. These are systems that assist older adults and people with disabilities to live more independently and to help reduce some of the physical burden placed on human caregivers. From a technical perspective, my group's research focuses on intelligent physical human-robot interaction, where robots are in close physical contact with people. And we're investigating how robots can safely touch people, apply force, sense, and manipulate both the human body and objects around the body. An example of what this close physical interaction can look like is bathing assistance, where a robot is using a wet washcloth in order to clean off a person's body. Or dressing assistance, where a robot is helping someone with disabilities put on a fresh set of clothes for the day or helping them get undressed in the evening. In this video here, we have a robot helping an individual with an amputation. What I'd like to share with you is just two of the many ways we're approaching the development of robotic caregivers. The first being how we're using simulation to develop robots that assist people. When it comes to developing robots that assist real people, there's in fact a lot of challenges. First, real robots and human studies are quite expensive. There are also risks with physical interaction, and we would never want a robot to accidentally hurt someone or put someone at risk. And lastly, collecting data on a real robot with real people is a pretty slow process. But what if we could use physics simulation to overcome these challenges? So towards this goal, our group has introduced Assistive Gym. This is the first open source physics-based simulation framework for modeling robotic caregiving and physical human-robot interaction. And with this simulation environment, we're now able to experiment with robots assisting many different types of people for many different daily self-care tasks. We can now benchmark caregiving and train assistive robots using advanced robot learning methods. And we can investigate the generalization of caregiving, including how robots can adapt to different people that have different impairments. One way that we've been using simulation is as a tool to safely evaluate and improve robotic caregivers. And we do this by using virtual reality. We bring people into physics simulation to safely interact with these assistive robots. We've also been using simulation to help robots learn common sense on how their actions will physically affect people. In these videos here, our robot is estimating how cloth is applying forces onto a person's body while helping that person get dressed, or while helping them clean off their body with a washcloth. This is what we call haptic perspective taking, or taking on a person's sense of touch. We've also been training real robots on how to manipulate blankets over people in bed. Interestingly, all prior research in this area of robotic caregiving has assumed that people in bed have no blankets covering them, which is clearly almost never the case. So we're developing methods that enable a robot to perceive and uncover a blanket from different body parts, such as just a person's arms or only their legs, and this helps get assistive tasks. It helps prepare a robot or other caregivers for providing assistance. But simulation can only take us so far. We ultimately need real robots interacting with real people. So another area of our research investigates the design of new sensors and sensing techniques for robots to better sense and interact with the human body. One reason why new sensing approaches are becoming so important is because of all the visual occlusions that occur during robotic caregiving. For example, about midway through this dressing scenario here, the robot's own arm and this fabric garment are blocking the robot's sight of a person. In fact, in this video here, the robot is using a new capacitive sensor that we've been developing that allows the robot to overcome these visual occlusions and track human motion in real time during assistance. So to do this, we design multidimensional capacitive sensors like the ones shown here. And these sensors emit an electric field, allowing a robot to estimate distances to nearby conductive objects, such as the human body. We then train these local pose estimation models based on capacitance data and use these pose estimates within a feedback control loop to servo or control the robot's gripper around the human body, which is shown in the video on the right here. And note that this is all happening without computer vision. We then conduct studies with both able-bodied participants and people with disabilities. And in this final video here, these capacitive sensors are allowing the robot to adapt to the involuntary vertical motions made by this participant with cerebral palsy while dressing both sleeves of a hospital gown. So with that, I'll just recap here that my research group is investigating how robots can provide physical care and assistance to people in need. And if you're interested in learning more, feel free to reach out to me.